So we're going to begin discussing what makes triangles congruent. Congruent means it has all the same shapes and measurements, or the same size, shape, and measurements. So if two triangles are congruent, you can match them up with rigid motions to map one onto the other. So they don't have to be drawn the same way. They could be flipped around. They could be reflected. They'd still be congruent if there's rigid motion. So if there's reflection, rotation, translation, then they would still be congruent if you can map one onto the other. The other thing is, like I mentioned first, you can compare their corresponding parts. So if all of their corresponding parts, their sides and their angles, if they're all congruent, then the triangles are congruent. So here's the definition of congruent triangles. Two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. All three sides are congruent to all three sides of the other, and then all three angles are congruent to all three angles of the other triangle. That would mean all their measurements are the same. All their sides are the same. All the angles are the same. So this little if and only if statement right here, that's called a biconditional. That's what's written right above. If and only if is a biconditional, meaning it's true forwards and backwards. So if you flip the order of that around, it would also be true. So if you know the triangles are congruent, then you know all their sides and angles are congruent. Or if you knew all their sides and angles were congruent, that means the triangles are congruent. So it works both ways. Definitions work that way also. So let's look at a couple of triangles here. We're going to decide if they are congruent, and then if they are congruent, we'll talk about some rigid motions that will map one triangle onto the other. So if they are congruent, all three of their sides need to be congruent to the three corresponding sides of the other triangle. So we've got a 1 meter side and a 1 meter side. We have a 1.7 meter side and a 1.7 meter side. Those are congruent. And then the third side is 2 meters and 2 meters. So all three sides are congruent. They need to be corresponding also, so not just looking at they have the same sides, to make sure that the angles are in the same place and all that sort of stuff, and then we'll discuss the rigid motion. So we have a 30-degree angle, yes. A 60-degree angle, yes. 90-degree angle, yes. And their angles are in the right spots. So like the 30-degree angle is between the 2 and the 1.7. The 30 degrees is between the 2 and the 1.7. The 90-degree angle is between the 1 and the 1.7. Same thing on the other triangle. So that means they are congruent. Everything matches up. All of their sides are congruent. All of their corresponding angles are congruent, which means we could map GHJ onto KLM by just doing a rotation. We'd have to just rotate and then it would match up. They would look side by side. So if you rotate this triangle, it would match up. It would look this way. H would be there. G would be down at the bottom if you rotated it 180 degrees. And J would go here. Fill in the measurements that go with that. That would be a 90-degree angle. This would be 30, and this would be 60. So once you get that rotation, you can see that everything is exactly the same. Why rotations are pretty easy to use to figure out if they are congruent. Because if you can mentally perform a rigid motion, you can see that everything matches up perfectly. So the rigid motion that we used here was a rotation 180 degrees and then they match up perfect. We would technically have to translate it a little bit to the right, but just seeing them side by side right now is good. So for these next two triangles, are they congruent? We've got 12.1, 7.9, 8.5. This one's 8.4. These sides are different. They are not congruent. So for these tick marks mean that they are congruent. So these sides are congruent. 2 tick marks is congruent to 2 tick marks. 71 degrees, 71 degrees, 38 degrees. It looks like everything's right. Everything matches. And you would just have to rotate around. So this R would rotate around to W, S could rotate around to V, and then T can rotate around to U. So the rigid motion will be a rotation. Looks like about 180 degrees. So now we're going to look a little bit more at the angles of a triangle. There's the triangle sum theorem, which just states that the 3 angles of a triangle always add to 180. The sum of the measures of the angles of a triangle is always 180 degrees. So if you know 2 angles, you can always find the third just by subtracting from 180. So for these 2 triangles, to figure out if they are congruent, we've got the sides match up. There's 1 tick mark to 1 tick mark, 2 to 2, 3 to 3. The sides all match up. They have the same measurements, same markings. And we've got a 45-degree angle, a 55-degree angle, 45 and 55, that matches up. Now, we said that the 3 angles have to add to be 180 degrees. So if the 3 angles add to be 180 degrees, that means we can figure out what this third angle is down here, angle L, just by subtracting from 180. So 55 plus 45 is 100, which means angle L is 180 minus 100, which is 80 degrees. Which means that the corresponding angle on the other triangle, right here, is also 80 degrees for them to be congruent, which means that now we can solve for x because it says find the value of the variable. So our equation, 5x plus 30 equals 80. Subtract the 30, you get 5x equals 50. So x equals 10. And then the little rigid motion that would make these 2 match up, it's just a small rotation where we can map J will be in the same position as M. Very, very small rotation. We could guess the angle degree if we really wanted to. Only a few degrees though. So for these 2, if they are going to match up, B would match with E, A with D, and C with F. So the rigid motion that would make them be in the same orientation, you would have to reflect it so that E would reflect up to the top, D and F would reflect down to the bottom. E would reflect to the top, D and F would reflect down to the bottom. It would be our reflection that would make that map. So then the 30-degree side would be on the right, 50-degree, or the 50, not degrees, 30 millimeter, 30 millimeter, 50 millimeters and 50 millimeters, those would match up, which means that this 2y plus 20 would match with the 20 or 36 millimeters. So you set those equal to each other. And then solve for y. So subtract the 20, you get 16. And you get y equals 8. For these two triangles to match up, we would have to perform the rigid motion of a reflection again. We'd reflect it sideways. And B would match with E, 112 with 112, 25 with 25. So 112 plus 25 is 137. To find the third angle, we subtract from 180. We get 43. So angle B up here is 43 degrees. Which means that that x plus 7 angle has to equal 43 degrees. X plus 17 equals 43. Subtract the 17. You get 26. And for this last pair of triangles, to match them up, L would have to match with P, K would have to match with N, and J would have to come down to M. So that looks like a rotation. To rotate it around like that. Which means that the 4y plus 12 would match up with the 32 millimeter side. So that's your equation. Subtract, you get 4y equals 20. So y equals 5.